Alright, little adjustment here. You're welcome to start these as soon as you can label them. Here's a few examples I want you to go through. This is kind of like your homework for the day because we're not going to be anything out of the book on this particular unit. Sorry about this. I found that if I record longer than 7 minutes, I lose everything. So I'm just going to do this in increments here. So this first one, find the area of a triangle, round to the nearest tenth. You'll see the base is 4, the two lengths on the side are 5, which means it is what type of triangle? Yes, isosceles. It is not right. You have to create your own right angle in there. I think you know how to do that by now, I hope. The middle figure, parallelogram. Talk about that one in a minute. The last one ends up being a trapezoid, but I don't want you to think of it as a trapezoid. Think of it as two separate triangles. If you're labeling it right now, it's got a diagonal here that absolutely is perpendicular to both of these, giving you this is 10, this is 6, this is 17. But again, that's two right triangles. If you work your way around that with the help of your good friend Pythagoras, you can find that area. So you may want to pause and do this on your own if you haven't done so. Otherwise, you can follow along here. Sketch an altitude in there. Use some Pythagorean theorem to find the length of that altitude. Of course, the area of a triangle is 1/2 base times height. I only gave you the base. I didn't give you that height. I believe this is where you find that height. 2 squared plus h squared equals 5 squared. This being 2. This being your h, and of course this is 5. So you're using Pythagorean theorem. You're not finding c. You're again finding a or b. And I think you get the square root of 21 if you do those calculations correctly. Once you got the height, you're good. 4 times rad 21. Don't forget to, again, divide by 2. I think you should get 9.2. If you're getting 18.4, you're probably just forgetting to divide by 2. Take the 1/2 because it's a triangle. Hopefully that makes sense. The second one, this 120 here is a helper, but it doesn't get you what you need, I don't think. It depends how you do this. I suggest if this is 120, you remember that's 120, and this angle here has got to be supplementary to that, so that should be 60. Once you've got that angle, it's pretty easy to look and go, okay, I got a base, 10 and 10, this is going to be my base. This is not my height, because it's slanted. I can sketch my height in here, and I can work with this little right triangle here on the left. So to find that height of that parallelogram, I think we use sine again. I believe you get 6.93 if you use a sine ratio. Some of you might also see it's a 30, 60, 90 over here. You could use ratios. Now this is 4, sorry, this is 8. This little piece would be 4. This would be 4 rad 3. So 4 times rad 3 is probably 6.93. Or you could use a sine ratio again to get that height. Once you got that, you're golden. Base times height. Again, the base is on the top in this case where it's labeled, but this is also 10. 10 by 6.93, 69.3 square inches, or inches squared. The last one. Look, there's 5 segments on that drawing. 3 are given. 2 you need to find using Pythagorean theorem. This one, if you look, they're both Pythagorean triples actually. This you can find from a Pythagorean triple. 6 squared plus b squared equals 10 squared. You might even recognize it as a 6, 8, 10. And if you do, that's fantastic. I'm proud of you. Well done. Pat yourself on the back. Yeah, pat yourself on the back. Do it. Okay. Same thing here. You can use Pythagorean theorem to find this one because they're both right triangles. You do 8 squared plus h squared equals 17 squared. And I believe that is, again, a Pythagorean triple. It's an integer value. I think you get 15 for that one. And from there, it's real simple. Find the area of each triangle, add them together, done. So, and again, when you're doing this, don't call this area 48. It's not 6 times 8. It's 6 times 8 divided by 2. So the area of this should be 24. The area of this one should be 8 times 15 divided by 2, which I believe is 60. And a lot of people always ask me, does it matter when you divide by 2? No, if you're smart, you realize you can divide by 2 in the beginning. It makes the number smaller. You could divide this by 2 and go 3 times 8 and get 24. You could divide this by 2 and get 4, and do 4 times 15 and get 60. You can do that at any step of the problem. You can divide by 2 in the beginning or at the end. Total area for that one should be 84 square units. Okay. Last two, I believe, that are basic problems on here. This one, sketch your diagonal in here. It's going to be a 5-unit diagonal, 5 units long, giving you a 40-degree angle. And save this one for a minute. I would start on this one. We'll come back and label that one in a minute here. Or you can pause it and do it on your own and then check to see if you got it right. That's probably the best way to approach this. Treat this like a homework assignment that you're now checking your answers with a solution from Mr. Hess. You'll notice I didn't give you anything on this in terms of base and height. You can't just do base times height because I didn't give you base and height. You got to use some trig to get those. So if you're trying to get the side opposite of 40, you probably realize you got to do opposite over hypotenuse. You got to do a sine ratio. If you crank that out, you get 3.21. If you're trying to do the bottom here, the base, it is adjacent to the 40. You got to do adjacent over hypotenuse, which is a cosine ratio. So you'll see why the publisher of the book put the trig chapter before this. They want to use and apply trigonometry to area problems. Give you a lot of practice with it. I believe you get 3.83. Once you got these two values, you're in good shape. Multiply the base times the height. And you'll notice I have 2 places here and 2 places here. It's because of my answer, I was thinking I was going to round to the nearest tenth. So I wanted to keep a few extra places. And I think in reality, when I did this on my calculator, I keep like 3 or 4 places and 3 or 4 places. It keeps me a little more precise at the end. So 12.3 square units. Alright, this one here, you're not going to solve for x and you're not going to solve for y. You're going to give your answer in terms of x and y. In other words, your answer at the end is going to be like 20xy. You're going to have an answer in terms of x and y. It's a little tricky. Base is 10y. And these horizontal sections are all in terms of y. This is 3y. This is 3y. Which if you think about it, this is 3y plus 3y, that's 6y. And the whole thing is 10y. That leaves 4y for this piece. And the same idea with your heights. The total height of this is 6x. Because you've got 2x plus 3x plus 1x. So you can break this apart into maybe 3 rectangles, maybe 2 rectangles, maybe 4 rectangles, different ways to do this. I chose to break it into vertical rectangles, with this one being the easiest one to get. The area of this in terms of x and y would just be 2x times 3y, or 6xy. 2 times 3 is 6. You can't solve for x and y. You don't have to. That's not the intention. The intention is to give your answer in an algebraic form. Same idea on this one. It's 3y by 5x. This entire thing is 5x, or 15xy. It's a little tricky for some people to get their head around where I'm getting those length and widths from. Just adding segments that are sort of implied on there. And then like I said before, this entire thing is 4y. This entire thing is 6x, which gives you 24xy. If you did this a different way, that's fine. Don't think you did it wrong. You might have divided it with horizontal lines on here. There's a ton of different ways to cut this up into rectangles. I believe at the end you should get a total of 45xy, which I would get from just adding these 3 spaces together. If you did it differently, just check to see if you got that same value.